Okay, in this video lesson, we're going to be solving systems of equations using inverse matrices. We're only doing a 2x2 system. We're going to make another video for a 3x3 system. But for this 2x2 system, here would be the example. And I know you could multiply, if you wanted to do linear combinations, you could multiply the top equation by 4 and the bottom equation by -3. That would cancel out the x terms. But I need you to know how to do this using matrices, using an inverse matrix. So what we want to do is we want to set up, we want to solve for x and y, but first let's go ahead and set up a coefficient matrix here with 3, 4, and you notice I'm taking the coefficients, 4 and then 5. And now we put the variables x on top and y on bottom. And that should be equal to -4, -7. This stuff right here. So that's what we're looking at. Let me get all this line back up for you. I was going to try to separate it a little bit, but let me just draw a line through here so we can tell the difference. And the reason why this makes sense is because if we take this matrix and multiply it by this matrix, don't we first multiply 3 times x, and then we're going to add 4 times y to it? And then that's the same way on the bottom. We take 4 times x, and we will add 5 times y to it. And that should be equal to -4, -7. So you're taking what you know about how to multiply matrices, and you are breaking this original system that we started with, you're breaking it down into matrices. Okay, so now, how do we solve and get this matrix by itself? Well, we just did this in the previous section. Multiply this by the inverse. And if we multiply that by the inverse, cancel those out, right? And that leaves us with x, y. And if we multiply the left side by the inverse, we also have to multiply the right side by the inverse. And then once we just multiply these two matrices, we have our answer. Seems simple enough, right? Just takes you to remember how to find the inverse of matrix A. So if we look here, let me go ahead and get that back on our screen. So we're going to say inverse of matrix A is 1 over the determinant of A. The determinant of A, so we should have 3 times 5, which is 15, and then 4 times 4, which is 16. We subtract those. What is 1 over -1? That would be -1. All right, 3 and 5 trade places, and these two become opposites. Now, once we do our scalar multiplication, it becomes a -5, it becomes +4, it becomes +4, and becomes -3. And so therefore, we have the inverse matrix right there in black. In order to find x and y, we just go ahead and multiply. Can we go ahead and multiply these? Because this is a 2x2 matrix, and this is a 2x1 matrix. The inside numbers are the same, so then our answer should be a 2x1 matrix, which matches that. Should be a 2x1 matrix. So far, so good. We're doing all right. All right, so this matrix xy should be equal to -5 times -4, which is 20, and then we add 4 times -7 to it, -28. And then we're going to go 4 times negative 4, which is negative 16, and then 3 times negative 7, which is 21. And let's go ahead and see what we have here. 20 plus negative 28 is negative 8. And negative 16 plus 21 should be 5. And so if we look there, we have found out what this is equal to. Remember, this is matrix x and then y. And so what's x equal to? X equals negative 8. What's y equal to? 5. And so you've just solved the system that we started out with. Negative 8, positive 5 is the solution to that system. All right, let's see what you can do there. In example number 2, all by yourself. And then we go from there. You can pause the video and then hit play and check to make sure that your solution matches mine. So let's set up the matrices here. So we're going to say 6, negative 5, 3, negative 2, xy, and that's equal to 3, 3. I don't know why I put a fraction bar there. 3, 3. All right, so we have them set up. So now let's determine what the inverse is. Let's say 1 over the determinant. What are we going to get? We're going to get negative 12 minus negative 15. And that should be, I think, 3, right? Yeah, 1/3. 6 and negative 2 trade places. 3 becomes opposite and 5 becomes opposite. All right. Multiply by the inverse. Those cancel. And now let's multiply this by the inverse. The inverse. So now scalar multiplication. Go ahead and do this. I believe we get negative 2/3. We get 5/3. 1/3 of negative 3 should be negative 1. And 1/3 of 6 should be 2. 3 here and 3 here. All right, I'm erasing this inverse matrix work. And that should be equal to x, y. Okay, let's go ahead and do our multiplication. Well, let's say negative 2/3 times 3 is negative 2. And 5/3 times 3 should be 5. Negative 1 times 3 should be negative 1/3. And 2 times 3 should be 2/3. And I'm getting in a hurry there. Because I had fractions on top, I kind of imagined I had fractions on bottom, but I really don't. Let's try this again. Negative 1 times 3 is negative 3. And 2 times 3 should be 6. Hey, there you go. I know my multiplication facts. On the top, negative 2 plus 5 should be 3. On the bottom, negative 3 plus 6 should also be 3. And so therefore, what are we going to plug in for x? X is here. Since 3 is on top and x here is on top, that's the reason why 3 becomes x. And then y is on bottom, 3 is on bottom, and there's our solution. There's our solution. That's how you solve a 2x2 system using matrices, more specifically an inverse matrix. that'll be the end of this video. Let me know if you have any questions.